let's do the 11th sum. In triangle ABC, this triangle ABC, ray BD bisects angle ABC. This angle is bisected. The bisector is BD. Ray CE bisects. Now this is CE is there. CE bisects angle ACB. ACB. Okay. So let's draw a diagram and understand. So we have triangle ABC. ABC. First one is a bisector. BD. And the other bisector is this bisector. It's CE. Easier. Seg AB is congruent to AC. AB, this whole thing, I'll show it here. AB is congruent to AC. We have to prove that ED is parallel to BC. Okay, now when you look at the figure itself, when you say bisector, immediately you will take the theorem of angle bisector, the property of angle bisector. What does the property say? The bisector of an angle of a triangle divides a side opposite to this angle, and it divides the side in the ratio of the remaining side. So let's write the sides which are in proportion. Which are the sides which are in proportion? That is AD is to DC. We are taking this bisector. Okay, BD is the bisector of angle ABC. And what is the proportion? AD is to DC is equal to, which is the remaining sides, it is in the same proportion as the remaining sides. It is the side which is AB is to BC. Okay, this is the first equation. Now we take the second bisector. We have taken the first bisector, that is BD. Now we'll take the second bisector, which is the second bisector EC, right? This is the bisector. EC is the bisector, and the sides which EC is bisecting, side which EC is bisecting is AB, and it is proportional to the remaining two sides, which is the remaining sides AC and BC. Okay, so which side we are going to write? We are going to write which is the side now? AE upon AB, right? And which is the remaining sides? AC upon BC. Okay, what is given in the given condition? It is given. This is the second equation. Okay, what is the given condition? AB is equal to, or AB is congruent to AC, right? Say AB is congruent to AC. AB is congruent to AC. Now you can see the denominators are the same. That means since they are equal, they are the same. Denominator BC and BC is the same. So denominator is equal. And the given condition is AB is equal to AC. That means this part, the right hand side is equal, right? AB upon BC is equal to AC upon BC. Because, why? Because AB and AC are equal in this condition. So these two equations, this side is equal. So automatically which side will be equal? When A is equal to B and C is equal to B, right? Because this is B, this is also B, I'll take it as B, this I will take it as A, okay, and this is C. Now B and B is equal, so what will be equal? Therefore A will be equal to C. Okay, I always give the example. Now suppose this is 5, the proportion is 5, it can be 1 upon 5, okay. I'll just take it as 5 or 5 upon 1, it is 5, and this, that is AB is AD upon DC is 5 or 5 upon 1 if I take it as 5 upon 1, and AB upon BC will also be 5 upon 1, right? And here we are saying that AC is equal to AB, AC is equal to AB, that means what? AB is 5, AC will also be 5. So finally what we draw a conclusion is this, that when A is equal to B and C is equal to B, therefore A will be equal to C. So what do we learn? When A is equal to B and C is equal to B, then A will be equal to C. Now which is A here? A is AD upon DC. And what is C here? AE upon EB. So finally we got AD upon DC is equal to AE upon EB. What we have to find? Okay, we have to find that they are parallel. Now we have found that they are in proportion. Which sides are in proportion? AD is to DC is equal to AE is to EB. Now this, when the sides are in proportion, which theorem will we use? We will use that it is the basic proportionality theorem. So by converse of basic proportionality theorem, we can say that ED is parallel to BC. What is the basic proportionality theorem? When a triangle is intersected by a parallel line, then the line which intersects the sides, it divides the side in the equal proportion. That was the basic proportionality theorem. And what is the converse? The converse will be when the sides are in proportion, when the two sides of a triangle are in proportion, this side, when the two sides of a triangle are in proportion, then the line which intersects, by which the sides are come in proportion, those lines will be parallel. So we have proved that ED is parallel to BC. So let's see clearly the proof. In triangle ABC, ray BD is a bisector. So this one is a bisector of angle ABC. ABC is here. So by the property of angle, bisector of an angle, which sides are in proportion? AB is to BC. That means remaining sides. Where it is bisecting, you take the remaining sides. Okay. And the side which is bisecting, it's in proportion. So AD is to DC. The first condition is this. Okay. Next bisector is CE, this one. C is bisecting which side? AB, right? It's bisecting AB. So these sides are in proportion. That is AE is proportional to BE. And which is the remaining sides? Remaining sides is AC and BC, right? So AC is to BC is equal to AE upon E is to EB. This two sides and the remaining two sides. Okay, so we have got the two statements. The first statement was AB is to BC, AB is to BC is equal to AD is to DC. And the second one was AC is to BC is equal to AE is to EB. And the given condition in the question was saying AB is congruent to AC. AB is congruent to AC. Now in the statement, AB and AC are equal in the given condition. That is, the numerator are equal, the given condition in the question, and the denominator is the same, BC and BC. That means these two sides are equal. I mean AB upon BC is equal to AC upon BC, right? So the left hand side is equal. When the left hand side is equal, then automatically the right hand side is also equal. Now this one, take it as A, this one is B, okay, and this will take it again as A because both are equal, A, and this is C. Now when A is equal to B and A is equal to C, therefore B will be equal to C, which is B, AD is to DC is B, and AE is to EB is C. So these two are equal, and so we have found from statement 1, 2 and 4, 1, 2 and 3 we have found this AB upon BC is equal to AC upon BC. We have found that, and then finally we have found from all these conditions, this is the fourth one, okay. From the fourth condition, that is from the first one is this, AB upon BC is equal to AD upon DC. Second one is AC upon BC is equal to AE upon EB. And the fourth one is, this one is the fourth one, AB upon BC is equal to AC upon BC, because AB and AC are equal. Okay, so finally what we got, AE upon EB is equal to AD upon DC, which I said is the first and the second and the fourth. B is equal to C. Okay, now when we find that the sides are equal, when we found that the sides are in proportion, which sides are in proportion? AC upon EB is equal to AD upon DC. So, the line is intersecting and creating these proportionality, those lines will be parallel. So, by converse of basic proportionality theorem, ED is parallel to BC. ED is parallel to BC. Okay, so ED is parallel to side BC, therefore AD is parallel to BC. So, we have proved the statement that we have to prove that AD is parallel to BC.
Thank you, dear children, and God bless you all.